Now, how do you find the vertex for the third one? Third one is not given to us in this format. So anybody can tell me what we're going to do with this? How are you going to find the vertex here? Okay, Elizabeth just type factor it. Factoring is not going to help. Anyone else? Those are with the microphone, you can just talk. You can click on the mic and tell me your step.
Simplify it.
Kyle's is simplifying it. Okay. Shabana says to change it to the binomial. Well, we can complete the square. That's one way. Completing the square means I have to look at these two terms here and complete the square. Anybody remember the method, completing square method? That's also something that you need to know for the next exam. How to solve by completing the square. How can I write x plus 2x as something square like this? Anybody remember that? You take the coefficient of x, you divide it by 2, and you square it. And that's the number you need to add here for these two. Let's do it both ways. This way, if I look at these two terms here, to see what I need to complete the square would be, this method only works when the coefficient of x squared is equal to 1, which in this case it is. You take the coefficient of x, which is 2, and you divide it by 2, and you square it. You always divide it by 2, and you always square it. So that becomes 1 squared, which is 1. So it means if I add 1 to these two terms, I can complete the square. Let's do that. If I add 1 here, we can complete the square. But if you add 1 here, you have to also subtract 1 at the same time. So I won't change the value of the original equation here. So y is equal to x plus 2x plus 1. I add 1 here because according to this method here, I need 1 to complete the square. And then at the same time, I'm going to subtract 1. So really, I'm adding 0 to this. That would be one way to make this look like the general equation of the parabola. And there's also an easier way too. I'm going to show you both ways. So in this case, if I factor this, after I find a number I need to complete the square, if I factor this part here, then this would be factorable. Not only would be factorable, also would be the same binomial for factor. X and x here, and then here would be 1 and 1, and both has to be positive. So it would be x plus 1 times x plus 1. In other words, I would get y is equal to x plus 1 squared. So if you find the number to complete the square, you can make this look like something square. Now these two terms would add up to -4. So here how you can find, we can change this equation into the general equation of the parabola by completing the square. So once I do that, then I can find what the vertex is. Yeah, this method is a longer method, but you need to know both methods. You need to know how to complete the square. Later, when you want to graph circle, ellipse, hyperbola, this is the same method we use for those also. So this is something that you also should learn. So let me ask Elizabeth. Elizabeth, what is the vertex after I complete the square and make this look like the equation of the parabola? Elizabeth, you have a microphone, right? No, okay. Elizabeth typed -4. The vertex is a point, so you have to give it to us as an order pair. Renee, I see you logged in late. Do you have a microphone? You want to tell me what the vertex is?
Yeah, I have a microphone.
Okay. Can you tell me what the vertex is?
Actually, no, I'm just writing the problem down.
Okay. So you want to compare this formula here with this and find what the vertex is. Let me go back to Kevin. Kevin, can you tell me what the vertex is now? Because you were getting this earlier with the other examples. What is H here, Kevin? This is kind of like the second example, Kevin, isn't it? Oh, wait a minute. I need to give you a microphone. Sorry. Go ahead.
Oh, thanks. Yeah, 1 and -4.
Okay. Why is it one again? This is plus, right?
Right.
So the formula says minus.
Oh yeah. Yeah, I'll have to get used to that. But okay, -1 and -4.
Here you go. Yes, line from
okay.
Very good.
Yeah, I definitely need to get on this section.
Yeah. So that is the vertex. Now there's a formula here to find the vertex if the question is not given to us in terms of the general form of the parabola, and that is v of x is equal to minus b over 2a, and that's what Catherine was posting earlier in the chat room, and she's right. This is an easier way to find the x position of the vertex. So let's find it. What is b here? Okay, this is a. The coefficient of x squared is a. Coefficient of x is b, and this constant is c. So what is b, everyone? Anyone? What's b?
The 2.
2, yeah. Elizabeth, you put 4. I didn't understand what you put minus. So b is coefficient of x, so it would be just 2. So it would be minus 2 over 2 times, what is a? A is the coefficient of x squared, right? Which is
1.
Okay, so v of x position of the vertex is equal to minus 2 over 2, which is equal to minus 1. And that's exactly what we calculated here. That's v of x position of the vertex. So I think this is a pretty handy formula right here. You should remember. So x position of the vertex is equal to minus b over 2a. Please make a note of this. Now once I know v of x, then I can put this, make a chart out of this. If x is equal to -1, what is y? Well, you substitute that into this equation here. If x is equal to -1, you substitute -1 for each x. You get -1 squared would be 1. Plus 2 times 1 would be 2, so 1 plus 2 would be equal to 3, right? Is that right? If x equals to -1, that would be 1 plus 1, and that would be minus 2. So minus 2 plus 1 would be minus 1. So minus 1 minus 3 would be minus 4. That's exactly the same answer we find earlier using the completing square method. So there are 2 different ways to find the position of the vertex. One is to find v of x, which is minus b over 2a, and then find the x position of the vertex, and then substitute that into the equation to find the y position of the vertex, or complete the square, get it into this form, and then look for h and k.